the product rule. First, what is the product rule? Well, it's a method used to find the derivative of a function. Using the definition given in our textbook, if f and g are both differentiable functions, then their product, which is p of x, would be f of x times g of x. Then their product, p of x, equals f of x times g of x, is also a differentiable function, and the derivative of p of x equals f of x times the derivative of g of x plus g of x times the derivative of f of x. What does this mean in English? It means that if you have a function composed of two smaller functions multiplied together, then its derivative is that formula from the last page. Then its derivative is what follows. It's essentially a recipe of what to use if you have a function that would normally be difficult to find the derivative of. Just think of it in bite-sized pieces. Now, while it looks like a pretty easy formula to follow, what can be difficult is identifying f of x and g of x, or seeing the two functions that are being multiplied. So let's try some practice. For each of the following functions, let's see if the product rule can be used and see if we can identify f of x and g of x, or the two smaller functions inside. For the first one, we have p of x equals x squared times ln of x. Can we use the product rule here? Yes, totally. And what would f of x and g of x be? Well, in this one, f of x would be x squared, and g of x would be ln of x squared. So we can use this information into the formula on the last couple of slides. But what about with this one? Q of x equals cosine of x divided by ln of x. Now this is one function being divided by another, so it's not something we can normally use the product rule for. However, there are some ways that we can manipulate functions in order to get it to... However, there are some algebraic manipulations we can use to rewrite the function to be a product of two functions, which is something we can use the product rule for. In this case, let's rewrite it as cosine of x times 1 over ln of x. It's the same exact function as the one listed above, but this time it's something we can use the product rule for. And then in the bottom derived q, and then in the bottom q of x, the two pieces of this function would be cosine of x, and the second would be 1 over ln of x. But let's actually try and solve one. What about this one? P of x equals 10x cubed plus 5x squared minus 7 times 20x to the 8th minus 7. Now, if we didn't know the product rule, the only way to solve this would be to use the power rule. But with two factors like this, we would have to factor everything out, multiply it, and get one long string, which would take a while, and which would just take a while. But luckily, we know the power rule, which can be used here. So but luckily, we can use the power rule. And so let's identify the two functions that are in this one. The first is f of x, which is 10x cubed plus 5x squared minus 7. And the second, g of x, would be 20x to the 8th minus 7. Now using our formula, we can leave f of x alone, and then times it by the derivative of the second, g of x, and then add g of x alone times the derivative of f of x. As long as both equations have their turn to be the derivative, it doesn't matter which order it's in. But I find to keep it f of x, g of x, g of x, f of x helps me to not forget any of the steps. Now let's try one more. How about p of x equals x plus 2 divided by 3, all to the power of 2? Now this one also doesn't look like something we can use the power rule for. However, but let's see if we can do some algebraic manipulation to something that we can use the product rule. Let's start by getting rid of the exponent. So we're exponent out the numerator and the denominator, which would give us x plus 2 to the x plus 2 squared divided by 9. And then if we were to factor out x plus 2, we would get x squared plus 4x plus 4 over 9. Now we can use the same method from previous with cosine of x over ln of x and turn it into x squared plus 4x plus 4 times 1 over 9. This bottom p of x is the same exact function as the top p of x, but now we have something we can use the product rule for. So identifying the two parts of this function, we have f of x equals x squared plus 4x plus 4, and g of x, which equals 1 over 9. Now using our formula, we can just follow the formula Now using our formula, we can multiply, now using our formula, we have f of x, x squared plus 4x plus 4 times the derivative of g of x, which is a constant, so it would be 0, plus the derivative of g of x, plus g of x left alone, times the function that times the derivative of x prime of x, which would be 2x plus 4. But this one, let's see if we can simplify this one a little farther. Since anything times 0 is 0, so we'd get 1 over 9 times 2x plus 4. Now if we just put that 1 over 9 back, we get 2x plus 4 divided by 9. An easy way to find the derivative of a previously hard function.